Alright, hey everyone. So mathematics tends to be reversible. The things we do that give us answers, we sometimes want to start with the answers and go back. And so what we've been doing here, whoops, as I kind of ended in the last one, there we go. Sorry. This new pen has a button on it and I keep hitting it every now and again. We would transfer from the x-score, the actual random variable, to the z-score, which would give us some probability. Now we want to be able to go from the probability back to the x. And so I think your book shows this nicely as being a bunch of directional arrows, and that you can also go in the reverse direction. And so we first started by going from z-scores to probabilities, and then we went from x values to z-scores to probabilities. And so what we're going to do here is we're going to go from probabilities to z-scores, and then once we have the z-scores, we're going to turn them back into our x values. And so I want to start with doing this on the table that we can do. We can use the table to reverse. So let's start here with a value of z, or of probability, equal to, let me draw my probability table here. I have some Pac-Man ghost, right? And these start looking like Pac-Man ghosts. And I have a probability that if I figured out this area, it would be equal to 0.3632. Now, a couple things to notice. This number is less than 0.5. And things less than 0.5 were negative z-scores, right? So if the probability is less than 0.5, the z is less than 0, which means it's negative. If the probability is greater than 0.5, then the z is greater than 0, which means it's positive. And so this being less than 0.5, we're going to have a negative z-score. So we're going to want to use the negative table. So we come over here. Well, there's all the videos, but let's go from the videos to the text, and we want a negative. And so we're looking for in here, and I'm going to expand this a bit. Let's see, is that still on the screen? Yeah, that's one of the problems with this web application from Pearson, is if I make it too large, it gives it a weird border. But it is what it is. So in here, I want to look for negative 3, 6, or I want to look for 0.3632. So I look for 0.3s, which are down towards the bottom here. And 0.36. So see how I'm looking at my probabilities? 0.3632. And that's on the column for negative 0.3. And if I come up here, it's at 5. Notice how I did this backwards. Before I did this number and read the probability. Here I'm taking the probability and realizing the first two digits are negative 0.3. And the hundredths place is 0.05. And so I'm able to write the z-score that goes with this probability as negative 0.35. Right? Negative 0.35. So you see how we have inverted our process. And in fact, the ability to invert a function is a requirement in a lot of mathematics. Well, let's look at this with our technology. Okay? So we'll come back here and we'll go to the TI-84. And so we're going to do the inverse of a normal. Notice we have an inverse norm. And we're going to say that the area we want is 0.3632. It's a standard normal, so we have a 0 and a 1 for our mean and standard deviation. And it tells us we have a z-score of negative 0.3499, or the negative 0.35, which is what we got looking it up on the table. Right? And so our calculator gives us the ability to invert the z-score itself. All right. Well, let's kind of look at this in a slightly different viewpoint here. Let's talk in percentages and convert percentages in. Let's play the whole gambit of what we can do. Let's say I'm looking for the score that's in the upper 10.75%. And so I want to find the z-score that's in the top 10.75%. Well, I have to play with my complements because all of my tables go up to, cumulatively up to. And so to find this z, I want 1 minus, well, let's convert this to a probability, 0.1075, right? And so I want to find the z-score of whatever the probability is up to this boundary, which is going to be, what, 0.8925? Let's see, 0, 0, 0, yeah, 0.8925. And so we want to find the z-score that's with the probability of 0.8925. So let's come back to our text here. We know this is positive. And so we want to look in here for 0.8925. And right here, it's at 1.24. 1.24. And so the z-score that is equivalent to the upper 10.75% is 1.24. Well, again, we can do this on our TIs. And we'll go to second and distribution, and we'll look for the inverse normal. We can do the whole thing. We want the area, which is going to be 1 minus the 0.1075, right? We can have it do the calculation for us. And it tells us, hey, look, 1.24. And so we get our calculator doing all the work for us on those. And that gives us the z-scores associated with a given probability. And probabilities and percentiles are the same thing. All right. What we're going to do next is we're going to convert z-scores into the x variables, and that will be on the next video.